Hello students, myself Dr. Pavani V, working as Associate Professor, Department of Pharmaceutics in GRCP, and this presentation is regarding Drug Excipient Compatibility Studies, shortly known as DEC studies. So basically DEC studies are an important part of pre-formulation studies, and when we formulate a drug into a dosage form, we will be using many excipients. So whether our drug is stable in presence of those excipients or not, that we need to confirm. If we know the interaction, if at all any interaction is going to be there, if we know that interaction, then we can take preventive measures to control that interaction so that we can design a stable and effective dosage form. So the stability of the drug in the presence of excipients is studied under this DEC studies. As the drug is in intimate contact with one or more excipients, the latter could affect the stability of the drug. So we need to know whether our drug is safe and stable in presence of excipients or not. So how do we know whether our drug and excipient are compatible or not? So first of all, we need to know what is incompatibility. It is the inactivation of drug through either decomposition or loss of drugs by its conversion to a less favorable physical or chemical form. So here there is a loss of drug or there is a chance for degradation of the drug. Ultimately, it is going to affect the efficacy of the drug and bioavailability of the drug. Hence, we need to know the incompatibility that can arise between drug and excipients. And moreover, drug excipient interactions are more frequent than excipient interactions. And conducting these studies will help us in selecting the excipients. We have plenty of excipients which we can find in the handbook of pharmaceutical excipients also. So we have plenty of excipients, and out of those excipients, how to select our suitable excipient in presence of which our drug is safe and effective. So for selection of excipients, these DEC studies are very useful. So coming to the importance of the drug excipient compatibility studies, the stability of formulation can be maximized because we are checking the stability of the drug in presence of excipients at varying temperature and humidity conditions. So we will get to know the stability effect of the excipient on the stability effect of the drug. So we can increase the stability of the formulation, and it helps to avoid surprise problems. When we convert the drug into the dosage form during the formulation of the dosage form, if at all any problem occurs because of the incompatibility between the drug and excipient, such type of problems can be minimized by conducting DEC studies at the pre-formulation stage, and it is a regulatory essential for IND submission. When we submit investigational new drug application, this data is compulsory, and we can overcome problems associated with incorporation of multiple excipients. By conducting DEC, we will get to know the data about the excipients and how they are going to interact with the drug. So when we go for the multiple excipients, this data will be useful. So how do we conduct these compatibility studies? Basically, we can conduct the studies by 4 steps. The first step being the preparation of the sample, how we are going to prepare the sample of drug and excipient together, and the application of the statistics to streamline the experiments, number of experiments, and the storage conditions for keeping the samples, and finally the analytical method by which we can determine the interaction. So coming to the first step, sample preparation, and we all know that when the sample is in liquid state, the interactions are at maximum and we can easily identify, but for solid state reactions it is difficult to identify the interactions. So for that one, we need to prepare 3 samples, sample A, B and C. In sample A, we will be taking a mixture of drug and excipient in 1:1 ratio. Though excipient is not used as that of the drug, means amount wise, both the amounts are not same, but still we can use in 1:1 ratio so that any possible interaction between the drug and excipient can be maximized. And in the sample B, we will be taking same 1:1 ratio of drug and excipient, but we will be adding some amount of moisture to that one, so that any interaction which can occur in presence of moisture can be determined. And the sample C, we will be keeping the plain drug without any excipients. And all these samples are kept for 1 to 3 weeks at specified storage conditions. And these storage conditions, it varies from study to study. and then the samples are physically observed, and then they are analyzed by suitable analytical method like TLC or HPLC or DSC or any other suitable analytical technique. And next step is the statistical analysis. Here for a drug we may be preparing number of dosage strengths and we may be preparing number of dosage forms. So for a drug to check drug excipient compatibility study for all these strengths and all these dosage forms, it may be many number of excipients, and conducting for all these excipients may be a cumbersome process. So in order to reduce the number of experiments, in order to streamline the more effective interactions, we can go for factorial or reduced factorial designs, so that we can reduce the number of experiments as well as speed up the process. And next is the storage condition. We can keep the samples at different temperature and humidity conditions, but in general a temperature of 50 degrees centigrade is used for storing the samples. And sometimes we may increase the temperature also. We may conduct the studies at higher temperature, so that if at all any interaction, possibility of any interaction is there, that can be hastened up or fastened. And coming to the fourth step, where we will be using various analytical techniques to detect the drug excipient compatibility. We can choose from thermal methods of analysis to spectroscopy or chromatographic techniques or any other miscellaneous techniques, like right from the use of DSC to the radio label techniques. Plenty of techniques are available. We can choose any one of the technique based on the type of the drug and And among all these techniques, DSC is the most commonly used method of analysis. So how we are going to detect incompatibility by using DSC? We all know about the basic thermogram of the DSC, and here we take the thermogram of the drug as well as drug and excipient combination, and we observe these thermograms for appearance of any new peak or any disappearance of already existing peak, and if at all any change is there in the area of the peak or enthalpy, or any change is there in the peak shape, whether it has become more straight or wider, and onset of peak, exactly where it is starting, and what is the melting point, is there any change in the melting point or not. So if at all any changes are there, means any new peak or disappearance of existing peak or change in melting point or peak shape or onset or area, so if at all any changes are observed in all these parameters, then we can say that there is an incompatibility between the drug and excipient. So once we select an excipient for the drug based on the type of the dosage form, we take the drug and excipient in equal proportions, that is 1:1 ratio, and we conduct DSC studies. So if there is no interaction between the drug and excipient, then we can recommend the excipient. But if at all any interaction is found, that is change in area or new peak like that, then we can go for TLC study. And if at all any significant breakdown is not there in the TLC studies, then we can recommend that excipient. And if at all any significant breakdown is there which is observed through the TLC breakdown, then we need to go for alternate excipient. So briefly, this is the flow sheet of how do we conduct the drug and excipient compatibility studies by using various techniques, and by these studies we can either recommend or reject an excipient for a drug and its dosage form. Thank you.